We're now on our final portion of this lesson, and we're going to talk about congruent segments. Line segments that have the same length are called congruent segments. They are not called equal segments. Equal segments would be two segments that are exactly the same segment. Congruent segments are more than one line segment that happen to have the same length. So here, segment AB and segment CD, these are congruent. I know they have the same length because that's what this tick mark means. If they both have one tick mark, that means they are congruent. Now they're not congruent because one has two tick marks and the other only has one. Now they are congruent because they both have two tick marks. As long as they have the same number of tick marks, they are congruent. So we can say that their lengths are equal. The length of AB is equal to the length of CD. Or we can say that the segments are congruent to each other. Segment AB is congruent to segment CD. I would never say this. The length of AB is congruent to the length of CD. That is not true. I would also not say that segment AB is equal to segment CD. That is not true. We can say the lengths are equal. Remember, with no bar over the top, that means the length of one segment is equal to the length of the other, or we would say one segment is congruent to the other segment. So that shows up a little fuzzy, but congruent is an equal sign with that over the top. Okay, so that's the symbol right there. Plot J, K, L, and M. So J is at -3, 4. K is at 2, 4. L is at 1, 3. And M is at 1, -2. Then determine whether the length of JK and the length of LM are equal. So here is segment JK, here is segment LM. We could use the ruler postulate where we do absolute value of distances, of the difference of the 2 points, but most of us are just going to look at this and count. Just make sure you don't count this as 1. You have to move before you count 1. 1, 2, 3, 4, 5. So JK has a length of 5. For LM, 1, 2, 3, 4, 5. LM has a length of 5. Are their lengths equal? Yes. The length of JK is equal to the length of LM. Okay, we're going to use this diagram to find the length of WX. So now we're doing a little bit of review here. We're going back to the segment addition postulate. So I know that VW plus WX equals 144. So 37 plus the length of WX equals 144. So I'm going to subtract -37 on both sides. W equals 144 minus 37 is 107. So WX is 107. Okay, and our last problem here, plot these 4 points, A, B, C, and D, and then tell whether segment AB and segment CD are congruent. So notice the different wording. Above it was whether or not they are equal. Now it's whether or not they are congruent. It's the same type of problem. It's just that the wording is different. This time we have bars over the top, and we're going to say if the segments are congruent or not. So AB is at -2, 4 and 3, 4. So there's A, B, and then segment CD at 0, 2, and 0, -2. Okay, now AB, 1, 2, 3, 4, 5. So AB, sorry here, AB has a length of 5. CD, 1, 2, 3, 4. So they do not have the same length, so that means that segment AB is not congruent to segment CD. And it's because the length of AB is not equal to the length of CD. Now above, we said they did have the same length, so we could also write segment JK is congruent to segment LM.